So in this video, let's take a look at the add actor local offset a little bit closer. And what I'd like to do is let's go into Unreal Engine. Let's go to Floater BP, click on Floater BP here, and in the details panel type float. And here where we see should float and initialize floater locations, make sure those are unchecked. Now let's go back to the C++, and here under if should float, because this is set to false in the blueprint, we should not get this if statement run. But let's go ahead and highlight add actor local offset and copy that, and let's go up to begin play, and just under this if statement, let's hit Control V. And so we're going to say add actor local offset, and we're going to need to create a hit result. So let's copy this f hit result, and paste that just above as well. Okay, so we're going to add actor local offset, and instead of initial direction, I want to create a new vector. And let's call this vector local offset, and let's set it equal to f vector and initialize it to 200.f, 0.0f, 0.0f. So effectively what begin play should do is add actor local offset by 200 units in the x direction. So let's compile this, and as soon as this is done compiling, we'll go back into the Unreal Engine editor. Okay, so let's go into the editor and let's take a look at this sphere, and I'm going to move this shape cube away just a little bit, and I'm going to go ahead and hit play, and it's still moving. That's because let's hit escape and click on the icosphere itself and come into the details panel and type float, and you'll see that should float is still true on this individual instance, and that's because this variable is editable on instances, right? It's edit anywhere. So go ahead and uncheck the should float on the actual instance, and then go back and hit play. You'll see that the icosphere actually doesn't move, and that's because if we go back, we'll see that add actor local offset still uses initial direction. Let's actually use local offset, which is what I was intending to use. So go ahead and compile that, and I can hit play again. See that it jumps to 200 units. I'm going to drag the player start over and down a little bit, so that way it can be more in the center of our vision here. So it down a little bit, maybe bring the icosphere up a little. Let's click on the actor itself, and let's think about what local offset means. Now, if I take this actor and I hit the E key and I rotate it a little bit, let's hit W, and you'll notice that the translation widget looks the same. But if we go up to this little icon here, it says cycles the transform gizmo coordinate systems between world and local space. What does that mean? Well, if you click on it, you'll look down at our actor and you'll see the gizmo is tilted. And that's because it is showing you local space. It's showing you that the Z direction for this particular actor is not the same Z direction as the world. Come back up to this and click on it. Now it shows the world, and that's why it shows you the world axes here for the X, Y, and Z directions. Go back up here and see that it's tilted because we actually tilted our actor. So if we look back in our C++ file, we'll see that our vector called local offset has a value of 200 for the X component. Now going back to the editor, our X direction is now up in this skewed direction because we rotated the actor. So if we click play now, you'll see that the actor was translated 200 units in a horizontal direction. Hit escape, you'll see it's down here, and hit play, you'll see it's up there. So this is precisely what is meant by add actor local offset. If you want to move the actor 200 units in the world X direction, well, there's a quite descriptive function called add actor world offset that we can use for that. So let's go back and change this to add actor world offset and compile this. And back in Unreal Engine, we can click on the actor. We can see that when this is set to show you local coordinates, we know that it's rotated a bit, but when we hit play, we'll see that it's translated along the X direction in the world. Go ahead and hit escape and hit play again, and you'll see now that if we start from the perspective of the player start, you can really see that it's moving along the X direction and not the individual actor's X direction, which is different. If you really wanted to do both, you could use both functions. You can use add actor world offset, and if we copy this and paste it under here, and instead of world, we can type local and compile this. Then when we go back and hit play, we'll see that both are actually applied, and so they're additive. So we can go back and delete that. Now, in addition to world offset and local offset, we also have world rotation and local rotation. And this is where I'm going to introduce you to a new type of variable, and that's called frotator. So let's make a couple lines here and make a frotator. You'll notice it's prefixed with an f, just like f vector, so it's a struct, and this has three components, sort of like x, y, and z, but these are not called x, y, and z components. They're called yaw, pitch, and roll components. So let's create an frotator called rotation, and let's initialize it to an frotator using the constructor that takes three float parameters, 0.0f, 0.0f, 0.0f. Now let's go ahead and delete this add actor world offset, and let's call the function add actor local rotation. We can actually pass in rotation, and this is one valid overload of add actor local rotation. So we can take this rotation rotator, we can hover over the frotator keyword, and you'll see that the first one says float in pitch, the second one says float in yaw, and the third says float in roll. So let's see exactly what pitch means by adding 30, and these are in degrees, so 30 degrees to the in pitch parameter for this frotator. So we're basically creating this frotator with the pitch parameter 30 degrees. So let's compile this, and let's go back to Unreal Engine, and let's click on the actor, and we'll go to the details panel to rotation, and let's zero everything out. And now what we can do is click play, and you'll see, and it might be a little hard to tell, but the icosphere is rotated upward just slightly. So go ahead and hit escape, and let's go to the floater BP, go to the viewport, and I want to add something to this actor so that we can kind of tell a little bit about its direction. So let's go to add component and type in static, and it shows a static mesh. It says shape cube, so it wants to give us a shape cube, but we can add this shape cube and we can rename it, and I'm going to call it axes, and I'm going to make sure axes is selected and come over here to the static mesh property for this component we just added. Click the drop down and type XYZ, and you'll see the XYZ axes. And so there are the XYZ axes that we imported as an FBX file. And you'll see that if we zoom in, we can notice our 3D widget has our X, Y, and Z axes for the object, and so this mesh that we added corresponds to that. So we can compile this and go back into the world, and we'll see that our particular actor has its X, Y, and Z coordinates represented by this static mesh component that we dragged in. Now, just so we don't get confused, let's click on this XYZ axes, the one that we had already, and let's delete that. So now there's only one, and this one is the one that's attached to our actor. So now if we hit play, you'll see that it's a little more obvious that we rotated this actor a little bit in local coordinates. And this shows us what happens when we add a rotation to the pitch component of our actor's rotation property. So go ahead and hit escape and go back, and we'll see that our first component to our F rotator, the pitch component, is 30 degrees. We can zero that out and hover back over it and see that the middle, the second parameter, is yaw. So let's add 30 degrees to the yaw in our add actor local rotation function call. So go ahead and compile this and go back to Unreal Engine. So we know that our actor's local axes are pointing in the same direction as the world axis directions, and of course we can also see that by looking at our actor's details panel and seeing its rotation is zeroed out. Now if we hit play, we'll see that our actor is rotated as if it turned its head slightly to the right. And in fact, it's turned by 30 degrees. Let's take our player start and bring it up above the actor so we can see this a little bit better. And let's hit the E key, and we'll use our green widget here to rotate it so that it's looking down. So make sure that this arrow on our player start is pointing down roughly in the same direction as our actor. And we can use W to scale it over and E to rotate it to where we get it just about right. So now if we hit the play button, we can see where the actor ends up, and if we hit escape and hit play again, we'll see the rotation happening. Now I know that this blue circle is getting in the way. That's actually the arrow component for our player start, but if you ignore that, you can see that when you hit play and hit escape, hit play again, you'll see that our actor is being rotated about the z-axis basically. This is what happens when you change the yaw. So let's go back to our C++ file, and instead of changing our yaw by 30 degrees, now let's hover over F rotator, and we'll see that the third parameter is called roll. Now let's go ahead and change this by 30 degrees, compile, and now we will see the result of changing the roll. So go back into the editor and take a look at where the actor is and click play, and you'll see that the actor was rotated about the x-axis. It's tilted up a little bit. Now if you think of the actor's x-axis as its forward direction, then you'll see that this is sort of twisting the actor around its forward vector. So it kind of twists it around the x-axis. Now use this in the tick function as well if we wanted to. Let's go ahead and highlight these two lines, copy them and delete them, and let's paste them in the tick function just under the if statement. And instead of 30 in the F rotator for the roll, why don't we just add a 1 here, because it's getting called every tick. We only want to set it to rotate a tiny bit every tick, because otherwise it would spin really fast. So go ahead and click build and go back into the editor, click play, and you'll see that add actor local rotation is being called, and it's adding 1 to the roll every tick. And so the result is a rotating actor. And we can actually come in and click on the actor and rotate it so that its x-axis is pointing upward. And now if we hit play, we'll see that the actor is still rotating about its own local x-axis and not the world x-axis. So that's pretty neat. Go ahead and click on the actor and go to the details panel and zero out its rotation so that it's aligned with the world axes again. So that's add actor local rotation. We can go back into C++ and change this to add actor world rotation, and the result is just as you would expect. It's rotating based on the world axes and not based on its own local axes. So if we have this set to rotate the yaw, it's going to rotate around the world z-axis and not its own local z-axis. So let's go ahead and hit play, and we'll see now that it's not actually rotating around any of its axes. It's rotating around the world axes. And so that's an important distinction that you should take note of, and this can help you decide whether you want to rotate around world axes or local axes. So that's the difference between world and local axes and add actor local offset, add actor world offset, and add actor local rotation and add actor world rotation. So now you have 4 very valuable functions that you can implement in C++ in your gameplay programming.